Hello, 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 everybody. Welcome back to question 16 on the University of Waterloo's Pascal paper from way back when in 2005. The digits 1, 2, 5, 6, and 9 are all used to form 5-digit even numbers in which no digit is repeated. The difference between the largest and smallest of these numbers is... Okay, so we need to have even numbers. So even means you can divide by 2 and get no remainder. To be an even number, we must end with an even units digit. Okay. Now the numbers we have to work with are 1, 2, 5, 6, and 9, if I recall correctly. Yep, 1, 2, 5, 6, and 9. Only 2 of these are even. So all the ones that you could create will end with either 2 or 6. Okay. So we don't need to write out all the digits or anything like that. We don't need to write out all these 5-digit numbers. We just need what? The difference between the largest and smallest numbers. So let's make the largest and smallest of these numbers. If you want to make a large number, a large 5-digit number, you focus on the leftmost digit and you make him as big as possible. So out of these numbers, what can we use? Well, we could use the 9. Okay. Now, well, how about the next digit? Well, you'd think it should be the 6, but you have to stop and think, should the 6 go here, or do I need the 6 at the end in order to make this an even number? Because if we just make the biggest number we can, we get a 1 down here. And that's not even, so that's not the sort of number we're talking about. So when it comes to placing the even digits, we have to stop and think, well, gee, what should I be doing? But it's okay, because we're going to put the 2 down here. So we'll put the 6 here to make it as big as possible. Because if we used any other number, 5 or something, as long as I get 6 and 2 like this, it's going to be bigger than if I had 9-5 or 9-2 or 9-1 or something like that. Now we still have to make this as big as possible, so we tend to go, so the 2 is used, the 6 is used, the 9 is used. We can't repeat digits, so we're going to go 5-1. Okay, so this is our largest number, and you'll notice that 2 at the end means he's even. How about the smallest? So we still get 1, 2, 5, 6, and 9. So if we want small, the opposite principle applies. We want the smallest digit to be our leading digit, because hundreds are much less than 800s, that sort of thing. So we'll put a 1 here. No harm there. How about at the 2 here? Well, again, we have to stop and say, we need a 2 or a 6 at the end. What are we going to use? Well, put the 2 here, put the 6 here. That way we get as low as possible, and then 5 and 9. And this is going to be the smallest possible 5-digit even number that we can make. So now we just subtract, and if you want to, well, I've already got these lined up. Or, of course, if we want to, we can just grab our calculator. Now I try and avoid the calculator, so I'm just going to subtract by hand, old school. So I'll change pen color. So can't take 6 from 2, so we borrow a 1. 6. Can't take 9 from 0, so we borrow a 1. 10 minus 9 is 1. Can't take 5 from 4, so we borrow a 1. Leave a 5 there, so we get 14 minus 5 is 9. 5 minus 2 is 3. And 9 minus 1 is 8. So 83,916. And that's the very first one. I just double check. Yep, 9 there. Yep. Okay. So there we go. And that's the best we can do given the constraints. So, thanks for watching and have yourselves a wonderful day, and join me for a future math video if you're so inclined.